Okay, so I just loosened all my 6 wheel nuts. Okay, now I'm going to take the wheel off and I'll show you what's going on with the, we'll start with the suspension system. Okay, so this is the suspension of the left front corner. So the first thing we talked about was the strut assembly. This is the strut assembly. You can see the coil spring right here, and underneath this rubber dust boot, if I can get it up, I don't know if I'll be able to. There we go. Maybe not. Anyway, underneath this this rubber dust boot here is the shock. There it is underneath there, you can see it. So this steel shaft travels into the shock or the strut assembly, and inside here there is a seal and an oil. And all it does is it dampens or absorbs all the up and down movement of the wheel. Okay, so this is called the McPherson strut. And the spring sits on this, what's called the lower spring perch right here. And this is looking inside the left front fender. And you can see how the strut assembly is fastened, and I'll show you under the hood. Okay, and it's fastened to the inside of the left front fender here. At the bottom of the McPherson strut, it is fastened with these 2 bolts right here, 1, 2, to the knuckle assembly. And the knuckle assembly is that assembly in there. Oh, look at my backing plate. Remember we talked about backing plates? Look how rusty this shield is, or this backing plate. It's rusted out, as you can see. It's supposed to come all the way down to the edge of the rotor, okay, and just keep any debris or dirt hitting the back of the brake rotor. Okay, so this is our knuckle right here, and it holds everything together at the wheel. You can see up there where the strut is bolted to the knuckle, up in there. Okay, so the knuckle is this whole assembly. It's the caliper anchor is bolted to the knuckle right here, 1 bolt there, and the other one's up in there. This is our drive shaft right here that comes from the transmission, and it's a rubber boot in here as well. Okay, because there's a joint in there, and you can see that the joint is turned right now because the wheel is turned. So the reason they call that a constant velocity joint is because it constantly sends power to the wheels no matter what direction. It's basically like a knuckle as well inside here. And there's grease in there, which is why we have this rubber boot. So back to the suspension. That is our McPherson strut. Okay? And this guy here is the knuckle that everything ties into. This is our lower control arm. Okay, the lower control arm on the inside, I'll give you a better visual here. So that's what we're looking at. The lower control arm has these rubber bushings, one there, and you can see how it's kind of suspended on the rubber bushing. And there's another one right here. Okay, the lower control arm is fastened to what's called the frame or the subframe, and the subframe runs all the way. You can see it going all the way down there. There's the other control arm on the other side, and the frame comes like this, the subframe. And the subframe is basically like the skeleton. Okay, it's what holds everything together. The engine and the transmission sit on the subframe. It's a very heavy, strong component. So the lower control arm is fastened to the frame by 2 bushings, one here and one there. And those bushings allow for the control arm to travel up and down as the wheel goes up and down. On the outside of the lower control arm, there's our ball joint right there. Okay, so inside the control arm here is the ball and socket joint, and it's fastened to the knuckle right there. You see that nut up there behind my finger? So the shaft of the ball joint goes through the knuckle, and it's held in place by that nut. So that ball joint goes through a lot of wear and tear because of where it's located. When you turn the wheel left and right, the wheel assembly, and I'll get Frank to turn the wheel, the whole assembly turns on this ball joint down here. So that is basically what we call the lower steering pivot. Okay, Frank's going to turn the wheel. You'll see everything turn. Okay, you see the CV joint turn as well. And he's going to go the other way. Okay, so you see the whole knuckle, the brake, the wheel, everything is turning left and right. The upper steering pivot, you can see the strut. Turn again, Frank. You see how the strut is turning with the wheel as well? So the upper steering pivot is the top of the strut, which is where the mount and the bearing is, up in there. Okay, because when you turn the wheel, everything turns with it. All right. There's my brake rotor. Okay, you can see how discolored it is because it's getting hot. My brakes are starting to wear out, and I'm going to have to replace those rotors. There is the end of the axle, okay, or my axle shaft, or my CV shaft, as some call it. Okay, so there's the transmission inside there, and the axle or the CV shaft comes out of the transmission, and it's powered now, and it's rotating. Okay, and it goes into the knuckle, okay? There is my brake shield, okay? That's my inside brake shield or dust shield, okay, or backing plate, okay? And it's, like I said, it's starting to rot down here and get rusty. This here is the hub bearing or the spindle. And you can see, I'll try and rotate it, it's hard. Yeah, it's hard to turn it, but inside this hub bearing, and that's what it looks like, it's bolted to the knuckle. There's my knuckle. It goes like that, down there. Okay, down here. And then, I don't know if you can see, not really, but there's the other part of the knuckle here. Okay, so it's all one big assembly. Okay, so the knuckle is what holds everything together. My hub bearing is bolted to the knuckle. There's one bolt there. One bolt right there you can see. And if we look on the back side, the bolts travel. Okay, there's one bolt there, one up there, and one on the other side. And the hub bearing is fastened to the steering knuckle, just like the strut is, just like the lower ball joint is, just like my drive shaft is, and then of course my my steering shaft right here, which goes into my rack right here. This is my what are called tie rods. Okay, this guy right here that goes up into there, into that rubber boot there, which is the steering rack. We'll talk about that in a second. Okay, guys. So here's the back of my frame, or what's called the subframe. And underneath the hoist arm here, the subframe is bolted to the body of the vehicle. And up in there, you can see that big bolt up there is the front of the subframe. And it goes, and the subframe is what connects all the steering and the engine and the transmission. This is the bottom of the transmission. That's the bottom of the engine. You can see my oil filter right there. Okay, so the subframe is what holds everything together and bolts it to the vehicle. So the next thing I want to talk to you guys about is what's called the stabilizer bar. The stabilizer bar, which is located right here, and there's different names for it. Okay, it's this bar right here. Some people call it an anti-sway bar or a sway bar. So the stabilizer bar travels across from one wheel on the front. There it is there. Okay, this steel bar right here. There it goes up there, right? It's hard to do with just me. There it is right there. And it comes out right here. So that's the stabilizer bar, and you can see on the end of the stabilizer bar, or the anti-sway bar, is what's called the stabilizer link. And the stabilizer link goes from the bar, and it goes up there, and it is bolted to the strut. One second. Okay, so back to the left front, there is my stabilizer bar, and you can see how it sits right here in this rubber bushing, and it is bolted to the top of the frame. The same thing on the other side, on the right front side, same thing. And then that bar comes and it's attached right here to the stabilizer link, and the link travels up and it's bolted to the strut right here. So the purpose of the anti-sway bar is just to prevent the vehicle from rolling too much or leaning when you take a turn. So picture yourself on an on-ramp going onto the highway. You know the big, long, winding on-ramps where you turn right for like 10 seconds to get onto the highway? Well, if you're turning right, which way is everything leaning, including you? Okay, because we're leaning. The anti-sway bar prevents too much lean. So the bar will actually resist the weight of the vehicle to lean onto one side as we are taking a turn. Because what happens to the contact between the tire and the road if we get too much leaning? Okay, so we're going to talk about that and the importance of the anti-sway bar and these links. So these links are similar to the ball joint in that right in here, right in this joint here, it's a ball and socket. Okay, so these guys go through a lot of wear and tear as well, and we replace these stabilizer links quite often, okay, because you get a noise associated with a loose stabilizer link. And I'll show you, okay, this one here is loose on my vehicle, this one right here, and I'll see if I can show you by wiggling the bar. It's not going to do it right now, but this this stabilizer linkage is it's actually loose in here. It's a ball and socket type of connection. Okay, so that is our sway bar or our anti-sway bar, and there is where it's bolted to the inside of the frame, right up in there. Okay, and there's the bar, travels along here. Okay, and there it's connected to the top of the frame on the driver's side, and there it is coming out here to the links. So together we call this independent front suspension. And the reason we call it independent is because each wheel moves independently of each other. Okay, so it makes for a more comfortable ride. That means that whatever's going on the driver's side underneath the tire or on the road is not going to be felt as much on the passenger side, because this wheel moves and operates independently up and down of the other wheel. If we look to the back of this old clunker, you can see here it's a different setup. There's our shock absorber. You see how rusty it is? There's our coil spring, okay? And this guy here that runs from the left rear wheel to the right rear wheel that goes to the left rear wheel, that is our rear axle. Okay, there is the shock absorber for the left rear wheel, and there is the spring. You see how thick and heavy this coil spring is? Okay, because it's holding a lot of weight. So this is not an independent suspension back here. This is a solid independent suspension system, meaning that whatever happens underneath the left front tire, okay, as far as road goes, it's going to be felt a little bit more on the right side because it's connected. Okay, so that is a non-independent suspension. Why is the front independent and the rear not? Well, they're more worried about what's going on in the front because that's sort of where the driver is, okay, versus the rear. And plus, this is just an old minivan. Most vehicles today have four-wheel independent and not just front-wheel independent suspension. Okay, so that's pretty much it for the suspension system. That's kind of the best I can do by myself here, trying to hold the light and whatnot. So a little bit about the steering system. The steering system uses a hydraulic, a steering pump to create pressure in a system to help assist us turning the wheels. Okay? If you try and turn the wheels of your vehicle with the engine not running, you'll notice it's very hard to do. When you start the engine, that circulates the pump, which creates pressure in a system, in the steering system, and that allows us to steer the wheels. While I'm down here, one of the components of the steering system is this guy here. We'll start at the end. This guy here is called the outer tie rod. Okay, and you can see the threads there. The outer tie rod is threaded onto the inner tie rod, and it is fastened to this guy, which is the knuckle. Okay, and there is the nut right here, and same idea, it's a ball and socket joint in here. Okay, because as we turn the wheel in and out, this arm is going to travel in and out, and it needs a place to swivel, sort of like our shoulder. When we move our shoulder left to right, the socket inside the joint rotates, right? Same idea with the tie rod. So this tie rod goes through a lot of wear and tear too, because think about when people hit curbs and they jam the steering suddenly. So this joint here wears out and it becomes loose, and then we get wheel movement when we don't want wheel movement. Okay, so we always have to check the front end when we have a vehicle up in the air to make sure that the lower ball joint isn't loose, and to make sure that the tie rod end isn't loose, and that's the outer tie rod end. Okay, the outer tie rod end is threaded onto the inner tie rod end, which is right here. And the inner tie rod end, as you can see, travels all the way in there to this component right here, which is the steering rack. It's very hard to see on this vehicle. You can kind of see it in there. I'll do my best here. And the steering rack, underneath that rubber boot there, is the steering shaft that comes from the steering wheel. So the steering shaft goes into the steering rack right here where these steel lines are. Okay, because remember I told you this is hydraulic, right? Oil's going through it. Okay, and the steering shaft goes into the steering rack and it converts the rotational motion. Okay, so you turn your wheel left to right like that, and the wheels go left and right like that. So the steering rack converts this motion into this motion of the wheels, and that all happens right here, right behind this kind of funny looking plug right here. Okay, because the steering shaft comes from the steering wheel through that rubber boot way up in there. And you can see how wet it is because my steering rack is leaking. Okay, and that's just a dust boot up in there. This is just a dust boot that protects the rack because there's fluid in there, okay, that helps us steer, and this dust boot keeps all the dirt and debris away from the end of the steering rack. Okay, so that's the left side of the steering rack. These lines right here, these steel lines that you see going into the rack, those are the fluid lines that give us the assist. They come from the steering pump. I'll show you that in a minute. Okay, and the reason we call it a rack and pinion is because there are two gears. The pinion gear, which comes from the steering shaft and goes into the rack, makes contact with the rack gear, and the rack gear travels the length of the rack and pinion steering assembly. So inside here there's a gear. I'm not going to talk too much about it because, well, it's better to show you in class, but you can see there's the other end of it down there. Okay, and you can see the fluid line right here. That fluid line goes up to the power steering pump, and I'll show you that in a second. This is looking at the right side wheel. Okay, there's our stabilizer bar right here. You can see it goes into that rubber bushing right there where it's fastened to the frame, on top of the frame on the right side. And there's the stabilizer bar, goes all the way through. There it is there, all the way to the left side. Okay, and it connects right here, as I said, to the right front strut up there. And above the stabilizer bar is the rack, the steering rack. You can see it coming all the way through from where I showed you. Okay, and there's the dust boot for this side to protect the seal that keeps the fluid in it. You can see this dust boot's a little bit wet, so my steering rack is leaking. Okay, there's the inner tie rod that comes from the steering rack, and it's threaded onto the outer tie rod right here, and it's connected to the steering knuckle right here, just like on the other side. So when I turn the wheel left to right, these rods move in and out, which in turn turn the wheel in and out. Okay? Okay, so now I'm looking under the hood now, and in regards to the hydraulic component of the steering system, because much like the brakes, it has a hydraulic and a mechanical component. This here, you can see it looks like a steering wheel on the cap. This is our power steering fluid reservoir. If I take the cap off and look down there, you'll see fluid, and that's my dipstick. You see where my fluid level is? It's kind of halfway up the dipstick there. This is a pump, and it's a pump that's driven by the engine via this rubber belt here that is kind of hard to see. That belt there that I'm poking on, okay? And this pump, when the engine is running, that turns the pulley that the belt wraps around, okay, a wheel similar to that wheel there or that one there, which is our alternator back there. And there's a couple more you can see down there. Okay, it's hard to see this power steering one because it's hidden behind these guys here. When the engine is running, it turns that pulley, which turns the pump inside here. This is the power steering pump. And that pump creates a pressure of fluid inside the steering lines, which are located right there. There's one and there's two. I'll put my hands on it so you can see. It's hard to do this when I'm all alone, but what can you do? There's one line there, and there's the other one line right there. So those two lines, one of them is a pressure line. So there's maybe however many pounds of pressure runs through the steering system, okay, that's created by the pump here. That pressurized fluid travels down the steering line to the steering rack. And we have another line that returns the fluid back to the pump. So it's a closed loop. Okay, the fluid goes from the pump all the way down that line, all the way to the steering rack, and then it comes back up through this line here, back to the steering pump. That's really all I'm going to say about that, and we'll talk about it more in class because I'll just be wasting your time without some good visuals and whatnot.